All right, this is Honors Algebra 2 Pre-Calc. We're doing 4.5 in Algebra 2, which is the last section in Chapter 4, which is matrices. So this is going to be solving systems of equations using matrices and Gaussian elimination, also called the row reduction method, by hand. So first and foremost, let me preface this with, this is one of those sections that you folks are not going to love me for. 4.5 in Algebra 2, 9.4 in Pre-Calc, related rates when we get to AP/AB, volumes of solids in revolution in AB and BC, convergence and divergence in BC. There are always a handful of sections that you don't love because they push you and challenge you a lot, and this is one of them. So don't panic. We're going to walk through it, and it's going to be fine. All right, so you know how to use matrices to solve a system of 3 or more variables with your calculator, but what would you do if you didn't have a calculator, right? Now, I realize that you generally have one, but sometimes you're not gonna. So we're gonna learn how to do this by hand because it's really hard to find the inverse of a 3x3 or larger matrix. So we're going to learn how to do this thing, Gaussian elimination, named after Carl Friedrich Gauss. We'll discuss him in Chapter 9 of Pre-Calc 2. Gaussian elimination, also called row reduction method, basically is similar to a regular elimination in that you will line the equations up the same way that you do. And then we're going to write them as what's called an augmented matrix. So let me just show you an example of what I mean by that. So when I say line the equations up, let's just pretend I'm just going to pick x plus y plus z equals 3, 2x plus z equals 3, and y minus 5z equals -4, just for argument's sake. Okay, and so here they're lined up where the x's are all in one column, and the y's are all in a column, and the z's are all in a column, and the equal signs are all in a column, and my constants are all in a column. Now you're used to seeing it where we have a coefficient matrix and also a variable matrix and then a constant matrix. But the way an augmented matrix works is it basically takes all of the coefficients of these guys. So these were all secretly 1s, right? And there's a 0y in here because we can't see it. And there's a 0x here, and that's a 1. Okay, so this would look like 1, 1, 1, 2, 0, 1, right? Because there's a 1 in front of that z if you don't see it. 0, 1, -5, right? But then instead of putting ending our matrix, we would put these little colons like this, okay? And on the other side, I would put what would be the constant matrix, would be the 3, 3, -4. And this is called an augmented matrix. Sorry about the random color switching. Okay, so this is called an augmented matrix. See how these constants are the ones I wrote in blue on the other side. And basically the equal signs are the colons, right? So they're not actually equal signs, they're colons, right? Just 2 dots, but that's what they look like, right? Okay, so that's called an augmented matrix. And so in an augmented matrix, this chunk would have been my coefficient matrix, right? And these guys would be my constants. Now, what you'll notice is missing is the variable matrix, but the columns represent those variables, right? This is my x's, these are my y's, these are my z's. So it's implied that each column represents each variable. Okay, so moving on. All right, so the row reduction method of solving a system of equations allows you to determine whether a system is independent, dependent, or inconsistent. This is really useful if your calculator fails. So this is useful if your calculator has an error, right? And we saw this at the end of the video for 4.4. If your calculator had an error, it meant that it was either a consistent dependent system or an inconsistent system, and we couldn't tell which. So we had to then use other methods, like solving for y to see if they are parallel lines. Well, if there's more than 2 variables, you can't do this by solving for y easily. Like it's not gonna be very easy. There are ways to do it, but it's harder. So it's more useful if you can see if you can use this method to see what the error is. All right. So the row reduction method is performed on this augmented matrix, right? We just walked through what one of them looks like. This is a particular example. Here's your coefficients, just like we discussed. Here's your constants, just like we discussed. All right. So basically the goal of the row reduction method is to change the coefficient matrix into the identity matrix, right? Which is a matrix that has 1s along the main diagonal and 0s above and below. So this is called reduced row echelon form. For the record, row echelon form would just be if these top numbers weren't 0. Okay, so if you didn't have the word reduced there, it would just be that these would be non-zero. But we don't want that. We ideally want reduced row echelon form, which means that the coefficient matrix is transformed through a bunch of elementary row operations into the identity matrix. And here's the reason that this ends up giving us the solution. So you can see in this problem that the variables were m, a, and n, right? So m, a, and n. So what this top row actually says is 1m plus none of the other two letters equals 8. Oh, well, look, that tells me that m is an 8, right? The same thing with the second row. It tells me that a must be a 7, and the third row tells me that, what was it, n? N must be 6, right? So essentially that's what this gets us, and that's called reduced row echelon form. In the next video, when we get to the second video in this section, we're actually going to talk about how you can make your calculator do reduced row echelon form for you, but that's not what I'm going to be looking for when I make you do it on a test. So we're going to walk through what these elementary row operations are. Remember, our goal is to take something that looks like this and make it look like the identity matrix, right? And whatever changes we perform, it's going to affect the other side as well, and we're going to walk through that. Okay, so here are the operations that we can do on the rows, right? Keep in mind that these are basically the same things that you can do to an equation, right? Because each row represents an equation, right? So remember that a row represents a full equation, right? So for example, when I had that x plus y plus z equals 3, right? The row in the corresponding matrix was 1, 1, 1, colon 3, right? That row represents that equation, right? And remember that each column is a specific variable, right? So this whole column was all the x coefficients, and this whole one was all the y's, this was all the z's, and this was all my numbers, basically, right? So that's how those columns work. Okay, so the things that you can do to a row are mostly things that you could do to an equation, right? So I can interchange two rows. Well, that makes sense because that's the same as switching the order the equations are written, right? That's just switching the order of the equations, right? It doesn't matter if I write x plus y plus z equals 3 on top of, I think I did something like 2y plus z maybe equals 3. Doesn't matter if I write them that way or if I write them with the 2y plus z on the top and the x plus y plus z on the bottom. It doesn't matter, right? So I can switch the order of the equations. I just switch an entire row. I can multiply all of the entries in a row by a number. Well, let's talk about that, why that makes sense. Okay, remember that multiplying an entire row by a number, let's say I want to multiply this whole row, so 2 times row 1, right? Well, that would just be the same as taking this entire equation and multiplying it by 2, right? The coefficients would now be 2x plus 2y plus 2z equals 6. Well, doesn't that make the row 2, 2, 2, 6, which is definitely the exact same information, right? So I'm allowed to multiply an entire row because essentially what I'm doing is multiplying an entire equation by the number 2. And you're allowed to do that as long as you multiply everything in the equation by the number 2, right? So that's why I'm allowed to do this. And the third one is add a multiple of a row to another row. Okay, well, let's think about why that makes sense. That's basically elimination, right? That last thing is what we do all the time for elimination, right? When you do elimination, right? So when you do something like eliminations, the reason you're allowed to do this, let's look at the example of if you took 2x minus 3y equals, I don't know, let's do 1, okay? And let's do x plus, sorry, my brain broke. Let's just do x plus y equals 3, okay. Let's say I wanted to use elimination. Well, the way I would usually use elimination is I'd probably target one of my variables. I'm just going to pick the y. I multiply this whole row. So remember, this first equation is like my row 1, and the second equation is like my row 2. Right? In order to eliminate, I'm basically taking row 1 and I'm adding it to 3 of row 2. Right? Because to do my elimination, I have 2x minus 3y equals 1, and 3 of row 2 would be 3x plus 3y equals 9. Well, I'm adding them together, right? I'm doing row 1 plus 3 times row 2, and sure enough, that's going to get rid of my y's, right? So we actually do this all the time, right? We do these skills all the time. It's the same idea. You're allowed to add a multiple of a row to another row, or subtract a multiple if you want to think about it that way, because you could multiply by a negative number, right? So all of these are operations that we're allowed to do on equations. That's why they work the way they work. But I do want to address one that you're not allowed to do. And I say this one specifically because somebody's going to try and do it, and so I want to get ahead of it. So what you're not allowed to do is add a number to each entry in a row. So you might be thinking, but Hogan, if I had an equation that looked like this, that's not a y, my bad. You might be thinking, but Hogan, if my equation looks like this, if I want to add 5 to both sides, I can't. Well, you're right, you can, but you end up with x plus y plus z plus 5, which doesn't fit in any of the existing columns, equals an 8. So that is not the same as adding 5 to each one of these, right? So if you have this row, sorry, I keep putting a line on top of that by accident. So let's say that you look at the row, right? You have this row 1, 1, 1, 3, right? If your logic is, oh, I'm just going to add 5 to all of them, that would be 6, 6, 6. Like if you think you can add 5, which you can't, right? This is false, but I just want to show you what happens. Wouldn't that look like this? Well, wouldn't that be the same as 6x plus 6y plus 6z equals 8, which is not true, right? That's not true. So the reason you can't add a number is that each column represents a different thing. The reason you can multiply by a number is because when you multiply, you're multiplying the x's, the y's, the z's, and the number. But if you add 5, you're not adding 5x, 5y, 5z. That's not how it works. So you can't add a number. Okay, so knowing that, we're going to walk through some Gaussian elimination. Now, if you absolutely hate this and you're like, Hogan, you've lost me and I'm done, the good news is that on my test, there are 2 questions like this and they're worth very few points. So it's to try and push you to do something that's a little bit difficult, and that's okay. But don't panic if this is not jiving with your brain. Okay, so let's walk through a really basic example. I'm going to be honest and say that there is no way I would do this with Gaussian elimination if I was not asked to do so, right? But I'm going to walk through basic examples. The first thing I have to do is I need to write this as an augmented matrix. It's already lined up, so that's good, right? 2, 3, 7. Okay, so when we do this, here's the idea. My suggestion, okay, so here's my suggestion on steps, okay? Work left to right on each, on one column at a time, okay? So I'm going to work left to right on one column until it's 1 and zeros. Okay, so I'm going to try and get each column. So I know I want this to be a 1 and it's already a 1, right? So that's great, right? That's already a 1. So what I'm going to do after each step is I'm going to label what my row is. This is row 1 and this is row 2. The reason I'm going to do that is that what I'm going to write is I'm going to write the name on this side, right? And then when I go to make a change, I'm going to write it on the left side, okay? So here's the change. My row 1 already has a 1. That's what I want. But I really want this to be a 0. So what I'm going to do is I'm going to take row 2 and I'm going to subtract double of row 1. Remember, I can't subtract a number. I can't subtract 2 from everything, but I can subtract multiples of the rows. So my row 1 didn't change. It's a 1 and a 4 and a 6, okay? But my row 2, right? My row 2 was 2 minus double this. Well, that's 2 minus 2, which is totally a 0, and I'm going to just make that 0 a smiley face because that's what I want. This, row 2 minus double this, would be a 3 minus 8, so that's a negative 5, right? And this would be a 7 minus double this, right? So that's a 7 minus a 12, which is also a negative 5, right? And then I'm going to go ahead and rename the rows because this is my new row 1 and this is my new row 2. When I make my next change, right, I'm going to list what I'm changing. Okay, so my column 1 is now done. Right, so this column officially at this moment, yay, it's done, okay? So now the next thing I'm going to work on is I'm going to work on getting this thing to be a 1, okay? So the easiest way to do that is to take my row 2 and divide it by negative 5, right? Because everything in row 2 is a multiple of negative 5. So I'm going to get that row 1 still hasn't changed since the very beginning, right? And when I divide my row 2 by negative 5, I'm still going to have that 0, right? I'm going to get a 1, which is exactly what I wanted, and I'm going to get a 1, okay? So now I rename my rows, call this row 1 again and row 2 because that's my new row 2, right? And I notice that the last thing I need to work on is this 4. I really need this 4 to be a 0, right? So I need this 4 to be a 0. The easiest way to do that, if we go ahead and go to the next line, is to take row 1 and subtract 4 of row 2, right? Which is the nice thing about this thing being a 1, because you can multiply 1 by stuff. So when I do that, so my row 2 isn't changing, right? My row 2 was already nice and happy and done. Okay. Now, when I do my row 1 minus 4 of row 2, well, the cool thing here is this is going to be a 1 minus 0 because 1 minus 4 times 0 is still 1, right? This is going to be a 4 minus 1 times 4, so 4 minus 4 is 0, which was the whole goal, right? And then this last one is going to be a 6 minus 4 times 1, so 6 minus 4, which is 2. So now, remember my first column was my x's, my second column was my y's, right? So that gives me the answer that x is 2 and y is 1. And you can go back up and check, you can plug those in. If you had x being 2 and y being 1, this would be 2 plus 4, which is 6. If you have x is 2 and y is 1, you get 4 plus 3, which is 7. So there's my answer. That's how we do it with Gaussian elimination. So what I want you to notice is in each step I need to communicate the changes I'm making. Now I do it this way, where I name them on the right and then make my changes on the left, rename them, make my changes, rename them, make my changes. The other way you'll see this done, and you'll see it done that way in the textbook, the other way that it's sometimes done, let me give myself a little bit of space, is they'll write the change above the matrix. So the other way that you could see this, and I like my way better, I think it communicates things more clearly. The other way you might see this first step, 1, 4, 6, 0, negative 5, negative 5, is where they say take row 2, take row 2 minus 2 row 1 and make that the new R2, which is what we did, right? So that's basically saying take this, make it this. Notice all they're doing is saying this is the only change we're making. Most of the time, especially early on when you do these problems, you're only going to want to make one change at a time. Now, it is possible when you have like 3 or 4 rows to make multiple changes at once, but again, as we do this, until we get better at it, we probably don't want to do it. So this is the way I like you to write it, but I don't care as long as you're communicating what's happening, okay? All right, let's go ahead and try a P1 rather. So you can pause me if you want to try this without me. It is already lined up. We're going to solve this using the same method, okay? Pause me if you want to do it without me. So 1, negative 2, colon 3 is my first row. 5, negative 3, colon 22 is my second row, right? So that's my row 1 and my row 2, right? So I want a 1 right here, which I already have. That's great. So that means I'm going to target this 5. So the first thing I'm going to do is I'm going to leave row 1 the same, right? But I'm going to take row 2 and subtract 5 of row 1, because that would be a 5 minus a 5, because a 1 times 5, and that'll give me a 0. So I'm going to leave my row 1 the same. Nothing changed, right? And it's still row 1. But my row 2, I'm going to take 5 minus 5 of these. So that's 5 minus 5, which is 0. That was the whole point, to make my first row done, right? I'm going to take row 2, which is negative 3, minus 5 times negative 2. So that's going to be a negative 3 plus a 10, which is going to be a 7, right? And then I'm going to take this 22 and subtract 15. So 22 minus 15 gives me a 7, and that's my new row 2. So this column is now done, right? I'm working one column at a time. My next target is going to be that I really want this 7 to be a 1. So my row 1 is going to stay exactly the same. It's going to be 1, negative 2, 3. Still my row 1, right? But my row 2, I'm going to divide by 7. So row 2 divided by 7 is going to give me that 0 divided by 7. 7 divided by 7 is 1. 7 divided by 7 is 1, and that's my new row 2. Well, now this guy, right, this guy's also done, so I just need to worry about this. So I'm going to take my row 1, and I'm going to add 2 of row 2. And I'm going to leave row 2 alone because it's totally fine. Okay, so when I do this, my row 1 plus 2 of row 2, well, that's going to be a 1 plus a 0, so that's still a 1. This is going to be a negative 2 plus a 2, so that's my 0 that I wanted, right? And then this is going to be my row 1 plus 2 of row 2, So that's going to be a 5. So my final answer ends up being that x is 5 and y is 1. And you can go back and double check to make sure you're right. That would make this a 25 minus a 3 is 22. That's right. And that would make this a 5 minus a 2 is a 3, which is right. So if I were asked to classify these because they have a solution and it is a finite specific solution, I would say that they are both independent. All right, cool. So let's go ahead and go to the book's first example. So the book actually starts with a word problem. I didn't start with the word problem because I think that's a lot. Maya and her friends Amit and Nina have a lawn care business offering 3 services: lawn mowing and edging, fertilizing and weeding, and trimming shrubs and small trees. They charge a flat rate for each service. The 3 partners divide up the work for a particular customer as shown below. So you can see the mowing, the fertilizing, the trimming. How much does each partner earn per hour, and how much will each partner earn in total for his or her work for this customer, right? So refer to the lawn care problem described at the beginning of the lesson. That's the one I just read to you. So if we make an equation for this, right? So if we make, and this is actually the problem that we saw that used m's. So I'm going to use m for Maya's rate. All right, I'm going to use n or a for Amit's rate. I'm going to use n for Nina's rate. So we know that Maya working 1 hour plus Amit working 1 hour plus Nina working 1 hour costs $21. We know that Maya working 2 hours and Amit working 1 hour costs $23. We know that Amit working 1 hour and Nina working 3 hours costs $25. So if we make this an augmented matrix, it's going to look like this. 2m, 1a, none for Nina, put my colon there, and no Maya, 1 for Amit, 3 for Nina, and 25. Cool. Okay, so we're then asked to use, we're going to be asked to use row echelon, reduced row echelon form method rather, or Gaussian elimination to go ahead and do this. So we're going to walk through it, but in order to do that, I'm going to take a quick little screenshot of this and I'm going to insert a blank page because there is just not enough space here. Okay, so we're going to go ahead and do, there we go. All right, so let's go ahead and start with this guy. All right, so I noticed a couple things, right? So I noticed that I usually start by column, right? So this 1 is already good and this 0 is already good. So I'm going to target this 2 for my first action, right? So I have a row 1, row 2, row 3, right? I'm going to leave row 1 alone and row 3 alone, right? The first thing I'm going to do is worry about row 2, okay? So I'm going to go ahead and just copy these here. All right, so I need to get rid of this 2. The easiest way to do that is to take row 2 and subtract 2 of the first row, because 2 of that 1 will take care of it. So I'm going to get 2 minus 2, which is 0, right? I'm going to get 1 minus 2, which is negative 1. I'm going to get a 0 minus 2, which is a negative 2. And I'm going to get a 23 minus a 42, right, which is a negative 19. Cool. Okay, so now column 1 is officially done. Great. I never have to worry about column 1 again. Okay, column 1 done. What this is going to mean, though, is I don't want to use row 1 to change either row 2 or row 3 because I want row 2 and row 3 to keep this 0 in this column. So the next thing I'm going to target, right, the next thing I'm going to target is that I want zeros here and here. Now, I did mention that sometimes it's worth doing 2 steps in one, right? I know I want both of those to be zeros, right? So the easiest way to make both of those zeros, if I want to do 2 steps in one, so this is my row 1, row 2, row 3, right? What I could do is I could take row 1 and just add row 2, right? Row 1 plus row 2 would give me a 0 in that spot. And if I did row 3 plus row 2, it would also give me a 0 in that spot. My row 2 doesn't have to change, right? My row 2 is 0, negative 1, negative 2, negative 19. Sorry, I forgot a colon up there. All right, so let's go ahead and do this. Row 1 plus row 2. So row 1 plus row 2 is 0 plus 1, which is 1, right? Because this is 0, this is 1 plus 0, right? Row 1 plus row 2 would be 1 minus 1, which is 0. That was the whole point, right? That was the whole goal. And row 2 plus row 1 would be a negative 1, right? Because this would be a 1 plus a negative 2, right? Row 2 plus row 1 would be a positive 2 because it would be a 21 minus a 19, right? Row 3 plus row 2 is still going to be a 0, right? Because I want to keep that as a 0. This is also going to be a 0 because this was 0 plus 0. This was 1 plus negative 1, right? This is going to be a 1 because it's a 3 plus a negative 2, right? And this one's going to be a 6 because it's a 25 and a negative 19. So it looks to me like in addition to getting those zeros, I actually already have finished row 3, right? It looks to me like row 3 tells me that, that the last person, who I think was Nina, earns $6, right? So I'm pretty sure that I now know Nina makes $6, right? What I'm now going to do is I can do a couple things. I can either, if you don't like this negative, right, one thing we can do to get rid of this negative is we can multiply by a negative 1, or I can start by dealing with these negative 2's and the negative 1. If you want to just finish out this column first, it's not a terrible idea to say, you know what, I just really want this to be a positive 1, so I'm going to do negative of R2, and I'm going to leave the other 2 alone, okay? And again, that's an extra step that you don't necessarily have to make. Like, you could probably do this separately. This was 0, 0, 1, 6, right? And that's going to be my R1, R2, R3. And this is going to be 0, regular 1, regular 2, regular 19. Cool. Okay, so now I've got 2 columns done. Columns done, columns done. All I have left to do is target these guys, make them zeros, and I can clean everything else up. So again, you can do that in one step using R3 because R3 is not going to mess up. So you don't want to combine row 1 and row 2 at this point. The reason you don't want to combine them is because row 1 and row 2 have zeros here and we want to keep those zeros here. But since row 3 has zeros everywhere except here, it's going to knock out those 2. Okay, so I'm going to use row 3 to get rid of those 2 numbers. So if you want, you could just do R1 plus R3, and you could do R2 minus 2 of R3 if you want to combine it into one step. That's your business. If you don't want to do that, if you need to separate them, that's fine. So remember, my row 3 has not changed, right? And actually has been done for quite some time, right? Okay, so row 1 plus row 3. Well, that's going to be a 1 plus a 0, which is a 1. It's going to be a 0 plus a 0, which is a 0. And it's going to be a negative 1 plus a 1, which is a 0. It's going to be a 2 plus a 6, which is an 8. Right? So there's my new row 1, and I'm pretty sure that tells me that Maya, who was the first person, makes $8, right? Row 2 minus 2 of row 3. Well, that's going to be 0 minus double 0, which is still 0. 1 minus double of 0, which is still 1. 2 minus 2, which is 0. That was the whole point. And 19 minus double of 6. So 19 minus 12 would be 7, and there's my row 2. So what that information tells me is that Maya makes $8 per hour. Was it Amit makes $7 per hour, and Nina makes $6 per hour, right? Cool. So if you actually go back if we go back a couple slides, you'll see that that's actually the exact answer that they got when they walked us through what an augmented matrix was. So that's the idea, right? That's how we do this. And again, I would probably answer in Word, so I'd probably say for Maya, for Amit, for Nina, okay? And then I believe they ask a couple questions. They actually ask, so now that we know how much they make, they ask the hourly wages, which we found, right? So we found that they were 8, 7, and 6. And then they say find the total amount that each person makes from the job. Well, it looks like Maya worked a total of 3 hours, right? Because she did 1 hour on mowing and 2 hours on fertilizing. So it looks like Maya made 3 times 8, so she made $24 on the job, right? Okay, and it looks like Amit also worked 3 hours, right? And I should have said like Maya total or something, because that's not what M is, right? So Maya's total was 3 times 8. Amit's total was also 3 hours times the $7 he made. So he made $21 for the job, right? And Nina worked 4 hours, right? If you look, see, these were 3 hours total, 3 hours total, and then Nina worked 4 hours. So 4 times her $6, she also made $24 for the entire job. Okay, so that's how much money they made. Cool. So moving forward. So we're going to go ahead and try a P2. And if you want to do this without me, you can go ahead and pause me. That's fine. Cool. So a company makes a total of 120 leather and imitation leather jackets per week. The leather jackets cost the company $200 to produce, and the imitation leather cost the company $50 each to produce. The company spends $12,750 per week on costs for producing jackets. Let X represent the number of leather jackets and Y represent the number of imitation leather jackets. Write a system of linear equations to represent the situation. Okay, so let's start with the system. So in A, right, we know that there are a total of 120 leather and imitation jackets, meaning that whatever X plus Y is, it's $1.20, right? We know that the cost of a leather jacket is $200, so 200 times X, plus 50 for the imitation jackets, and that's apparently 12,750, right? So that's my system of equations, although I kind of ran out of room for it. So that was A. B, write an augmented matrix and then use the reduced row echelon method to solve the system and find the number of each kind of jacket. So when we go to do B, right, I'm pretty sure it's going to look like a 1, 1, 120, 200, oh, that's going to be hard to fit, 50, really big number that I did not give myself enough space to write. Okay, cool. You get the idea, right? And this is my row 1, and this is my row 2. Okay, so first thing I noticed is that this is already a 1, so I'm going to go ahead and target this 200, right? So I'm going to leave row 1 the way it is, 1, 1, 120, okay? And I'm going to do row 2 minus 200 of row 1. I just kind of ran out of space. So that's going to be a 200 minus a 200, right? Because 200 minus 200 times this, which is going to be a 0. It's going to be a 50 minus a 200, which is going to be a negative 150. And it's going to be a 12,750 minus, if you double this, right? If you times this by 2, you would get 240. But you're tacking on 2 zeros because you're timing by 200. So this is 24000, right? So I'm pretty sure you get 1125 with a 0 on the end. I'm going to double check my math on that. But so if I do 11,250 divided by, oh, sorry, I'll explain why I'm doing that in a sec. Cool. Oh, sorry, it's negative because brain. Okay, anyway, so this is my R1 and this is my new R2. So the reason I was dividing is because I know that what I want is I really want this to be a 1. So I'm going to leave R1 the way it is, but I'm going to take my R2 and divide it by a negative $1.50. When I do that, I get 1, 1, 120. I get 0, 1, and then what I was trying to do, but I forgot about the negative, I'd get a 75 because the 250 was also negative, so I get a 75. So I get 75. Cool. So now my row 2 is actually done, right? I have row 1, I have row 2, and the thing I want to target is this guy right here, right? So in order to do that, I'm going to take my row 1 and just subtract row 2. And I'm going to leave row 2 alone. Well, row 1 minus row 2 would be 1, 0, right? And then 120 minus 75 would give me a 45, right? 0, 1, 75. So what that tells me is 45 leather and 75 fake leather, right? So we'll say faux leather because I'm too lazy to write imitation. Okay, so 75 leather, 75 faux leather or fake leather or imitation leather, and 45 of the leather. Okay, and that's the idea. Cool. So we're going to stop here because this has been a pretty long video, and then we're going to go ahead and do another one of these elimination problems with 3 variables in the next video. and after that, we'll learn how to do this on a calculator too.